Ever wondered what it takes to get a massive hunk of metal soaring through the sky? It's a vehicle that flies by gaining support from the air. But how does it beat gravity? Well, it uses either static lift, dynamic lift from an airfoil, or direct downward thrust from its engines. Think of airplanes, helicopters, airships like blimps, gliders, paramotors, and hot air balloons. All these are types of aircraft. Each one has its own unique way of staying afloat and navigating through the skies. The fascinating world of aviation doesn't stop at flying. It encompasses the entire human activity surrounding aircraft. And the science behind it? That's called aeronautics. Designing, building, and perfecting these flying machines is all part of this incredible field. Now, let's talk pilots. Crewed aircraft are flown by onboard pilots. But did you know? Some aircraft don't need a human at the controls at all. Unmanned aerial vehicles or drones can be remotely controlled or even self-controlled by onboard computers. Aircraft can be classified in many ways. First type is lighter than air, also called aerostats. Aerostats use buoyancy to float in the air in much the same way that ships float on the water. They are characterized by one or more large cells or canopies, filled with a relatively low-density gas, such as helium, hydrogen, or hot air, which is less dense than the surrounding air. When the weight of this is added to the weight of the aircraft structure, it adds up to the same weight as the air that the craft displaces. Small hot air balloons, called sky lanterns, were first invented in ancient China prior to the 3rd century BC and used primarily in cultural celebrations, and were only the second type of aircraft to fly, the first being kites, which were first invented in ancient China over 2,000 years ago during the Han Dynasty. A balloon was originally any aerostat, while the term airship was used for large, powered aircraft designs, usually fixed wing. In 1919, Frederick Handley Page was reported as referring to ships of the air, with smaller passenger types as air yachts. In the 1930s, large intercontinental flying boats were also sometimes referred to as ships of the air or flying ships, though none had yet been built. The advent of powered balloons, called dirigible balloons, and later of rigid hulls allowing a great increase in size, began to change the way these words were used. Huge powered aerostats, characterized by a rigid outer framework and separate aerodynamic skins surrounding the gas bags, were produced, the Zeppelins being the largest and most famous. There were still no fixed-wing aircraft or non-rigid balloons large enough to be called airships, so airship came to be synonymous with these aircraft. Then several accidents, such as the Hindenburg disaster in 1937, led to the demise of these airships. Nowadays, a balloon is an unpowered aerostat and an airship is a powered one. A powered, steerable aerostat is called a dirigible. Sometimes this term is applied only to non-rigid balloons, and sometimes dirigible balloon is regarded as the definition of an airship, which may then be rigid or non-rigid. Non-rigid dirigibles are characterized by a moderately aerodynamic gas bag with stabilizing fins at the back. These soon became known as blimps. During World War II, this shape was widely adopted for tethered balloons. In windy weather, this both reduces the strain on the tether and stabilizes the balloon. The nickname blimp was adopted along with the shape. In modern times, any small dirigible or airship is called a blimp, though a blimp may be unpowered as well as powered. Next type is heavier than air, also called aerodynes. Heavier than air aircraft, such as airplanes, must find some way to push air or gas downwards so that a reaction occurs, by Newton's laws of motion, to push the aircraft upwards. This dynamic movement through the air is the origin of the term. There are two ways to produce dynamic upthrust: aerodynamic lift and powered lift in the form of engine thrust. Aerodynamic lift involving wings is the most common, with fixed-wing aircraft being kept in the air by the forward movement of wings, and rotorcraft by spinning wing-shaped rotors, sometimes called rotary wings. A wing is a flat, horizontal surface, usually shaped in cross-section as an aerofoil. To fly, air must flow over the wing and generate lift. A flexible wing is a wing made of fabric or thin sheet material, often stretched over a rigid frame. A kite is tethered to the ground and relies on the speed of the wind over its wings, which may be flexible or rigid, fixed or rotary. With powered lift, the aircraft directs its engine thrust vertically downward. V-STOL aircraft, such as the Harrier jump jet and Lockheed Martin F-35B, take off and land vertically using powered lift and transfer to aerodynamic lift in steady flight. A pure rocket is not usually regarded as an aerodyne because it does not depend on the air for its lift and can even fly into space. However, many aerodynamic lift vehicles have been powered or assisted by rocket motors. Rocket-powered missiles that obtain aerodynamic lift at very high speed due to airflow over their bodies are a marginal case. From the Wright brothers' first powered flight to the cutting-edge technology of modern jets, heavier-than-air aircraft have revolutionized the way we travel, explore, and connect with the world. As we look to the future of aviation, the sky is not the limit. It's just the beginning. The relentless pursuit of innovation continues to push the boundaries of what is possible in the world of flight. One of the most exciting developments on the horizon is the advent of electric and hybrid electric aircraft. These aircraft promise a future of quieter, more environmentally friendly flights, reducing our carbon footprint while maintaining the speed and efficiency we've come to expect. With advancements in battery technology and electric propulsion, companies like Airbus and Boeing are already testing prototypes that could revolutionize air travel. Another groundbreaking innovation is the concept of urban air mobility. Picture a cityscape where air taxis seamlessly transport passengers above the bustling streets, reducing traffic congestion and cutting travel times. Companies like Uber and Volocopter are at the forefront of making this vision a reality, with vertical takeoff and landing VTOL aircraft designed for short, efficient urban flights. The exploration of supersonic and even hypersonic travel is also gaining momentum. Imagine crossing the Atlantic in just a couple of hours, or traveling from New York to London in the time it takes to watch a movie. New technologies and materials are being developed to make high-speed travel not only possible, but also safe and economically viable. And let's not forget the ambitious goal of space tourism. Companies like SpaceX and Blue Origin are working tirelessly to make commercial space travel accessible to ordinary people. The prospect of orbiting the Earth or even visiting other planets is no longer confined to science fiction. It's a tangible future that is rapidly approaching. As we advance towards these new frontiers, the spirit of innovation that propelled the Wright brothers' first flight continues to inspire us. Rotorcraft. Rotorcraft, or rotary wing aircraft, use a spinning rotor with aerofoil cross-section blades, a rotary wing, to provide lift. Types include helicopters, autogyros, and various hybrids such as Aerodynes and compound rotorcraft. Helicopters have a rotor turned by an engine-driven shaft. The rotor pushes air downward to create lift. By tilting the rotor forward, the downward flow is tilted backward, producing thrust for forward flight. Some helicopters have more than one rotor, and a few have rotors turned by gas jets at the tips. Additionally, some feature a tail rotor to counteract the rotation of the main rotor and to aid in directional control. Autogyros, on the other hand, have unpowered rotors, with a separate power plant to provide thrust. The rotor is tilted backwards. As the autogyro moves forward, air blows upward across the rotor, making it spin. This spinning increases the speed of airflow over the rotor, providing lift. Rotor kites are unpowered autogyros that are towed to give them forward speed, or tethered to a static anchor in high wind for kited flight. Compound rotorcraft have wings that provide some or all of the lift in forward flight. They are nowadays classified as powered lift types and not as rotorcraft. Tiltrotor aircraft, such as the Bell-Boeing V-22 Osprey, along with tiltwing, tailsitter, and coleopter aircraft, have their rotors or propellers horizontal for vertical flight and vertical for forward flight. These versatile machines play a crucial role in various sectors, from military operations to emergency medical services, and even in everyday transport in remote areas. Unpowered aircraft. Gliders are heavier-than-air aircraft that do not employ propulsion once airborne. Takeoff may be by launching forward and downward from a high location, or by pulling into the air on a tow line, either by a ground-based winch or vehicle, or by a powered tug aircraft. For a glider to maintain its forward airspeed and lift, it must descend in relation to the air, but not necessarily in relation to the ground. Many gliders can soar, that is, gain height from updrafts, such as thermal currents. The first practical, controllable example was designed and built by the British scientist and pioneer George Cayley, whom many recognise as the first aeronautical engineer. Common examples of gliders are sailplanes, hang gliders, and paragliders. Balloons drift with the wind, though normally the pilot can control the altitude, either by heating the air or by releasing ballast, giving some directional control,